In this video, we'll learn about the order in which our Python code is evaluated. It's important for you to understand the order of evaluation so that you can understand why your programs work in the way that they do. Taking the time to understand the order of evaluation now will be extremely beneficial to you as you work your way through the course and start writing even bigger, more complex programs. For algebraic expressions, like 3 plus 1 times 4, the algebraic precedence rules from arithmetic apply. So in this case, the 1 times 4 would be evaluated first, and then 3 plus 4 would be evaluated for a result of 7. And we can see that if we run this cell. Brackets would change the order of evaluation as they do in arithmetic. So with an expression of 3 plus 1 in brackets times 4, first the 3 plus 1 would be evaluated to become 4, and then 4 times 4 would be evaluated for a result of 16. And again, we can see that if we run this cell. If you're unsure about the order in which some code would be evaluated, remember that you can always write a small example to test it out. That's a great way to learn. Try to think of a small example that highlights the question you have. Perhaps I'm wondering if evaluating an exponent has a higher precedence than multiplication, or vice versa, or if they're the same and will be evaluated left to right. I can think of an example that could test this. To denote an exponent, or raising one number to the power of another, we use the star operator in Python. Maybe I'll try 4 to the power of 2 times 3. Based on the algebraic precedence rules, I would expect that 4 would be raised to the power of 2 first. So 4 times 4 is 16. And then 16 would be multiplied by 3 to get 48. But let's check to see if Python evaluates this code in the way that I expect. And it does. I can see after I run the cell that the result is 48. If it first evaluated 2 times 3 to get 6, and then raised 4 to the power of 6, the result would have been 4096. And we could see that using brackets. So if we said 4 to the power of 2 times 3 and run that, we see that we get a different result. For assignment expressions, something like x equals 4 plus 5, the expression on the right is evaluated first. Then the result is assigned to the variable, in this case x. It's important to remember that the entire expression on the right gets evaluated before the assignment. That will help you understand why your program, or somebody else's program, works the way it does. Remember that when an assignment expression is evaluated, in this case, x gets or is assigned the value 9, the variable is assigned to, and then the entire statement, the entire assignment expression evaluates to none. This is why we do not see any output when I run this cell. However, the statement was executed. If I want to see x's value, I need to access x's value by using its name like this. Now if I run this cell, it will show me the result of the last line of the last expression, which in this case is accessing the value of x. It's important to remember that an assignment statement evaluates to none, because otherwise we might assume that nothing happened when an assignment statement was run, when it's the last line in a cell, due to the fact that we can't see any output. Now let's think about how function calls are evaluated. First, let's define an example function. This function is named sayHi, and it has one parameter called text. The function body, or the code that is indented inside the function definition, on line 2, is not evaluated until the function is called. The function is called by using the function's name and giving an argument or input for the parameter. If there was more than one parameter, we'd have to give one argument or input for each parameter. Here's an example function call to the function that has the name say hi. So I've used the function's name and I've given one input for each parameter, which in this case is exactly one input. So let me run this. And we can see that the output is hi friend. Let me do another example. When I call the same function with a different input, I get a different output, as we would expect. I get hi Hashem. When a function call is evaluated, the arguments or inputs are assigned to the parameters, and then we evaluate the body of the function. In this case, the body only consists of a return statement. To evaluate a return statement, first the expression on the right is evaluated, and then that value is returned to the caller of the function. The caller of the function is the code that called the function. In this case, we return to the line in this Jupyter Notebook cell where the function was called. If the body of a function contained more lines than just this example with one return statement, then all of those lines of code would be executed following all of the evaluation rules. Let's consider an example that involves two function definitions. Here's another function definition. This function's name is shout, and it takes some words, and as you can see, it adds an exclamation mark onto the end of the words, because when we're speaking loudly, we might denote that in text with an exclamation mark. We could call shout like this. Here we're calling the function name shout. We're providing one input, in this case the string hi wanna, for the parameter. And then the body of the function will be evaluated, which takes the value for that parameter and adds an exclamation mark, or appends an exclamation mark onto it. So let's run this code. And we see that we get the result that we expect. Alternatively, we could call our say hi function and pass its result to shout like this. In this case, the argument to shout gets evaluated first. The argument to shout is itself a function call. So in order to evaluate that, we follow the steps to evaluate the function call to say hi. To evaluate the call to say hi, wanna is assigned to the parameter text, and then the function body is evaluated. Because this function body contains only a return statement, remember that we will evaluate the expression on the right, which appends hi comma to the front of the parameter, which in this case is wanna, and then it will return hi wanna to the place in the code that called say hi. That is then the input for shout. So now we're calling the function shout with the input hi wanna, which will then assign the input hi wanna to the parameter words, and then evaluate the function body, which will return hi wanna with an exclamation mark appended to it. So let's run this code, and we see we get what we expect. Now note that I talked through all of the evaluation steps, but you cannot see them happening. So you cannot observe these evaluation steps. And that's why it's so important to understand the order in which the code will be evaluated. It will really help you understand what's happening when you run your programs or when you run programs that somebody else wrote.